All right. The time is now 11:02 Eastern, and welcome to this developer show and tell session at Build with Mapbox. Really excited to take a step away from just talking about our tools and products and actually start showing what people are building. And we have a great show for you today with a lineup of 13 speakers. Very excited to see kind of a full breadth of not only subject matter, but people from all over the world who are going to be presenting. We have indie projects from solo developers up to full companies with things built by engineering teams. We've got games, data visualizations and dashboards. We've got third-party utilities that people have developed. We've got apps for cities and mobility. We've got web and mobile apps represented here during this presentation, and even some storytelling and news apps. So really exciting to see what we've got to share with you today. A little bit of housekeeping. So captions are available in multiple languages. If you want to turn those on using the Zoom settings, you'll be able to get live translated captions. You can submit your questions through Q&A. I think we have that enabled for this session. Like I said, we may not have a whole lot of time for questions, so we'll see if we can slide them in if there's time, but we're going to move very fast because we only have 5 minutes for each presenter. You have a chance to win Mapbox swag with every session you attend. I think this is one of the last, but we do have a Q&A session, or sorry, an Ask Me Anything session right after this one. So sign up for lots of these. Hope you've enjoyed Build and the other sessions we've been doing. And hopefully you'll get a chance to get some of that great Mapbox swag. And then everything will be in the Zoom lobby or on mapbox.com/built when we're /build, sorry, when we're done. So everything will be on YouTube, so you can check it out later. So here's our group of speakers today. So like I said, we have a great amount of representation from all over the world, from different size projects, different size companies, different size, different subject matter. So without further ado, let's jump in and let's see what people are building with Mapbox. And we're going to start with Nono Umasi, who's going to share Nono's Odyssey. So let's jump in. Nono, welcome to the stage. Do we have Nono coming out? Here he is. Welcome.
All right, so should I just go ahead and start?
Go ahead. The floor is yours. You got 5 minutes. I'll interrupt you when you start running out of time, but go ahead and show us.
Awesome. Sure. So I'm going to take the music off, but I built this because I was living in Athens and I wanted to just do a walk around my neighborhood. And what you're seeing right now is I'm able to control this character using just arrow keys. And this is actually the Acropolis. And it's populated right now with these data points, which I'm using from Wikipedia data. So it's this Wikipedia API. I can click on anything that has a speech bubble, which opens up this sidebar. It gives me a little bit of information on it. And I'm using OpenAI, so I can actually ask stuff about, like, tell me more. Okay. And so I can essentially interact with the environment that I'm in. And it'll give me this. It could be copied. It could be read aloud. I'm using just the web speech API to enable that. And so now this is a multiplayer game, so more than one player can actually join here. I haven't tried it yet. I built this about 2 months ago, so I haven't stress tested, but you should be able to join in and you can have multiple people just to walk about. The little shadow effect you see, that is actually inspired by Harry Potter. I was watching the movie, the first one, and I thought, you know what, I'd put that in there. We're actually walking to my neighborhood that I live in Athens, but you know what? Let's go to Tokyo. This is another one of my favorite places. So you can just basically teleport yourself magically around the world. So now we're in Tokyo. I'm just going to zoom out just so you can see the sky tree. Last time I visited, I actually lived here in Sumida part. And let's just do one more.
So real quick, wherever you go, you're pulling in real-time markers from the Wikipedia API to put on the map. Is that right?
Yes. Yeah, so I basically every time it moves, and if it stops for 5 seconds, it'll ping the API and it'll populate whatever it is. And I'm using turf, by the way, to buffer a certain radius.
Great.
So, right, for example, here, let me see if I zoom in. Actually, let's go to the Eiffel Tower. See if there's anything there. It probably should be.
And
Okay, so wait for
is that search box powered by Mapbox also?
it is actually okay, the Google Places API is actually populating this.
Okay.
Yeah. So as you can see here, we've got three items here that I can click on. And anytime I get close enough, actually I need to zoom in. If I get close enough to this item, it'll turn on, it'll give me some points. So I added some gamification to it there. So I get some points that if I interact with it, I get more points. And then because I wanted to do something with the points, you can use this boost thing here. It'll make you go faster. So anyway,
Yeah.
and if you can hear my sound, I don't know if you heard my sound, it would actually be a visual cue or an audio cue that it's on. And I can save this location so the next time around, I don't have to, go, go through all this stuff. It'll just record it. And I'm using local storage on the web API just to save where the location is. See where else. Well, I'll show you where I am. So this is currently where I'm in right now in Greece. It's a little village in the Peloponnese. And I'm really surprised that there is a Wi-Fi here. And I'll zoom in, zoom out. I'm probably out of time pretty soon. So this is where I am.
That's great. You got about a minute left, but I'm just curious, what's the motivation for this, and have you shared it? Has it been well received? Are people interested in it?
Yeah, I wanted just to find a way to just do a walkabout around the world, and I wanted to interact with maps. I think like everyone here, I love maps, and just to be able to like actually interact with your environment. I'm just using Wikipedia right now, but imagine if you could actually use something like Google Places API or Yelp API or Foursquare. You can actually talk to the environment. Like you can talk to a business and ask, what hours are you open? What's your holiday? What's the best dish? All that stuff. And with conversational AI, like using ChatGPT to power the conversation, you can actually talk to either real people or you can talk to NPCs or businesses. And so the use cases right now is, I think it's unlimited. I just wanted to build a prototype just to see what I can do with it. Like, right now you can just do like walking tours, for example.
Hmm.
Yeah, and I haven't shared it with anyone yet. So,
Well, you shared it with us now, so everyone go check it out. I think the link is in the chat. So thank you so much, Nono, and well, we have to move on to the next presenter. So really appreciate you sharing what you built. I see another player running around the map, so really love this. Thank you so much.
you're welcome.
Okay, so next on our list we have Clay Koberline, who is the lead software engineer at Drone Deploy, is going to talk about their migration from Leaflet to Mapbox GL.js. So go ahead, Clay, and the floor is yours.
Thanks, Chris. Over at Drone Deploy this year, we've undertaken a fairly ambitious project to swap out our mapping framework from Leaflet to Mapbox GL. So wanted to just share a little bit of that journey with everyone today. This is me. Feel free to reach out after on LinkedIn. I would love to connect with everyone. So just a little bit about the project to start with. Some of the motivating factors was improving the customer experience. Investing in our core product. Mapping is kind of the central focus. So improving the experience there, improving the developer experience within our engineering org as well. Many times the current mapping framework and our abstraction around it has been difficult to work with. So being able to leverage something like Mapbox to improve DX and then setting ourselves up for the future. So without further ado, so a little bit, just real quick, I want to dive into the meat of it, but Drone Deploy, so we're a full reality capture platform, allowing customers to bring in like aerial imagery from drones to ground capture data from Insta360 cameras, even to completely automated robotic data capture as well, and full kind of end-to-end solution from capture to upload, processing, and then enabling analysis workflows. So just kind of setting some context here. Here's some 3D views as well as some of the 2D views within our product currently. Um, and then here's a look at some of our interior kind of ground data where you might have a floor plan and media captures as well as walk paths being shown on the floor plan. So first off, kind of why Mapbox, right? There's all these mapping platforms out there. Looking at it in comparison to Leaflet, it's under very active development. The big thing for us was how well it handles data at scale. And then just the leveraging of standards as well as the APIs and tools that Mapbox has built around their product to kind of enable additional workflows. So, one of the big ones for us was Mapbox Studio. It's been a big efficiency boost for the team. We've been able to leverage different styles for exterior as well as our interior views. The custom imagery there in the screenshot has been probably the biggest difference in developer experience and efficiency. So we use SVGs for our markers, and we've just been able to upload those into Studio. They come down in the sprite sheet when we get the style, and we can just reference them by a string on the GeoJSON properties. We standardized around some of the naming conventions to make things very repeatable and predictable. And then the filter expressions let us just leave that as a generic lookup on the properties, and everything kind of gets pulled in from the data. So by comparison, we had SVG strings hard coded in, and with properties that would get substituted in. Developers looking to add in or modify marker content previously would be touching anywhere from like 8 to 14 different files and levels of code to get a marker on the map, which was just tedious, cumbersome, pretty much every bad adjective you could think about. So yeah, this is awesome. You touch about 3 files, maybe open up a small couple pull requests, and then the big thing is if we want to update the styles, there's no code involved. We get in touch with our design team. They drop us some new SVGs, put them in Mapbox Studio, and we're done. Kind of touching on data at scale, we do take advantage of Mapbox clustering capabilities, but just for illustration purposes on the screenshot, I've left that out. So there's 979 photos represented in this image on the markers. The way Leaflet handles that, there would be DOM elements for all 979 of these, which really starts dragging the browser down heavily when it comes to performance. So leveraging Mapbox here, rendering it all to the canvas element, very efficient, very smooth and easy to interact with, as well as like the set data calls to update everything in the background.
I got to cut you off, Clay. So thank you so much, but we're at time and we got to move really fast or we're going to run way over. So
understood.
Thank you so much. Yeah, thank you so much for sharing, and excited to hear that you know, you've modernized and you're having a better developer experience and a better product. So thank you so much. Okay, our next presenter. Thank you for coming out. Madeline Chapman, cartographer at, I don't know if it's SICU or SIKU, but I'll let you introduce it. But go ahead, the floor is yours.
Hey everyone, I am Madeline Chapman. Thank you for introducing me. I will jump right into my presentation. I am the cartographer with SICU, the Indigenous Knowledge Social Network. SICU is a mobile and web application by and for Indigenous communities. In the North, maps and map services are an important component of travel planning, environmental monitoring, and knowledge communication. SICU is a place where users can find marine and terrestrial information, Indigenous place names, satellite imagery, and weather services combined in one convenient mapping tool. The SIKU base map combines topographic data, bathymetric data, and more over the Canadian Arctic and internationally to provide Indigenous harvesters with a place to visualize important land information alongside wildlife, sea ice, tool, and trip posts. Our users who primarily live in remote communities across the north can download base map tiles and take that map out on the land. Mapbox is a powerful tool that is invaluable in giving us the capacity to share the information we need with our users. Due to the large volume of data hosted on the SIKU base map and the need to provide accessible offline downloads for map tiles at reasonable speeds, we sometimes push the limits of our Mapbox tools. Here are some of the ways that we, along with our partners at Mapbox, have found creative ways to optimize our maps. The SIKU base map currently holds 293 layers coming from 15 different tileset sources. We use advanced filtering directly through the Mapbox tiling service and JSON recipes to allow us to fit the maximum amount of data into our single style. We allow simplification where possible and reduce simplification where we need detail the most for safety. This filtering, as well as restricting zoom levels for individual layers, leaning on Mapbox's over capabilities for the remaining coverage, allows us to optimize our tile sets and get the most out of the space we have. Most of our users are in the Canadian Arctic, so we upload high-resolution data sets for this region. However, we want our users outside Canada to also have access to topographic and bathymetric data as well. Since we don't have the capacity to develop and maintain the same custom high-resolution data for the whole world, we leverage Mapbox global data layers for that coverage. Since we can't clip this data to only appear outside of Canada, we've developed a custom geofence to avoid data overlap with our Canadian layers to get the best of both worlds. By placing this custom layer, a polygon in the shape of Canada, it's set the same color as our background and it's set above our global layers, but below our custom Canadian data. We can eliminate data overlap and host detailed Mapbox data in regions that we've not yet expanded to. Because the SIKU base map displays topographic and bathymetric data together, we can run into discrepancies where those two layers interact with each other at the shoreline. Though both data sets are the same resolution and scale, their data is not necessarily co-located, which can present potential safety hazards for users navigating on the water or land. Our solution to this has been to develop a custom polygon layer that allows us to visualize the difference between these two layers. This way, users can make informed decisions when trip planning and have the most up-to-date and comprehensive information possible. This is just to reiterate, just to go over some of the things that, some of the solutions and key challenges that we've faced, all the things I talked about. So filtering to fit as many layers as possible into our style, our custom geofence so that we can sort of get the best of both resolutions, and sort of juggling those two different shorelines. SIKU was officially launched at the end of 2019. By now, SIKU is being used by nearly 30,000 users in regions spanning from Alaska to Greenland to James Bay and the high Arctic. By leveraging our partnership with Mapbox and the tools and capabilities available to us, we're able to consistently bring new features and add suggested content from our team's engagement across our SIKU communities and beyond. Lastly, I just want to leave you with a really short story from one of our partners in Nunavut that illustrates how powerful our Mapbox-powered maps are to people in the north. In the spring, 3 youth left their remote community by skidoo without telling anybody. Their skidoo broke down, leaving them stranded. One of them was able to take a screenshot of their location on SIKU, and they were able to walk to a location, thankfully, with service, and they were able to share their SIKU location on Facebook, I believe, and they were rescued shortly after, thankfully. And just to finish off, I'd like to thank everyone, and especially Mapbox, for allowing us to do what we do. And please feel free to get in touch. I'm happy to answer any questions that anyone may have.
Okay, thank you so much. I have questions, but we don't have time for me to ask them on air. So I'll bring
Okay.
out the presenter.
I'll be around.
Jump into the chat if you have questions for Madeline, and thank you for
Mm-hmm.
sharing that story and the great presentation. So next, let's call Nicholas Mariniello, founder and developer for the iOS Sunlit app. Welcome, Nicholas. The floor is yours. Go ahead.
Okay, thank you, Chris. All right. So, hi everyone. My name is Nicholas, and I am one of the founders and developer of Sunlit. Sunlit is an app that tracks the sun path and movements in the sky anywhere and at any time. It's an year-round guide to the sun and shade, and it's available on iPhone, iPad, and Apple Watch. Many sun tracking apps already exist, and they're often quite complex to use, with walls of text and numbers and a poor user experience. As developers, we're kind of into it, maybe, but with Sunlit, we wanted to be different. We wanted to build something that was as friendly and as accessible as possible for everybody, from casual users to the most professional ones, without compromising on aesthetics or usability. People all around the globe are using Sunlit in the most unexpected and creative ways, going from the everyday usage, like taking care of a plant or parking the car in the shade, to professional needs, like finding the best light for a photo shoot, or discovering sun exposure for real estate, or even planning outdoor events, and many, many more. Sunlit is built around the user, capturing the essence of light and shadow. At its core is the monolith, a 3D object casting its shadow on the ground based on the position of the sun. By dragging the side sliders, users can adjust the date and time inside the app. Gorgeous visuals and animation will react and communicate the sunlight changes throughout the day. This monolith mode provides a quick yet engaging user experience. However, for a more in-depth exploration, Sunlit's Explore mode simulates the sun's path anywhere in the world, and is powered by Mapbox. By combining our sun calculations with Mapbox lighting system and its standard map style, we were able to develop a shadow map. Sunlit provides precise and realistic building shadows across the world for any given date or time. And it's truly a game changer for real estate or architectural applications. Pushing even further, we merged hillshade and terrain layers into our map site collection, increasing realism and fidelity. Developing the shadow map was extremely fun. Some calculations are complex, but they've also been the same since forever. What we do with our in-house technology is computing the sun's spherical coordinates, which are the azimuth and altitude. And we do that by using inputs like the user's latitude and longitude, the time zone, date, and time. After that, we're able to compute the light source direction inside the map, along with its light and shadow intensities, and apply these changes inside the Mapbox environment, using its SwiftUI integration and declarative APIs. We're continuing to integrate Mapbox capabilities into Sunlit. This includes experimenting with Mapbox Studio, exploring various map styles, incorporating custom 3D models inside the map, and even providing offline map capabilities. We have several ideas already in development, and we look forward to release these features in the near future. So I'm here to answer any question you might have, but in the meantime, scan the QR code, download Sunlit, and start enjoying the sun.
We have about 50 seconds left in your time slot. So can I just ask, what's the, like, is there a package or framework or something that helps you out with kind of these animated overlays that you're using under the hood?
For sun calculations, there are plenty of frameworks out there, but we developed an in-house technology, so we call it SunKit. and it's actually open source and available on GitHub. And we use that just to compute the sun data, like the azimuth, the altitude, and also the timings for solar events, which are the sunrise, the sunset, golden hours, blue hours, and so on.
I see. Awesome. Okay, well, thank you so much. If you have any other questions, I think Nicolas can answer them in the chat. And next, thank you so much, Nicolas. So next, I'd like to call out
Thank you.
Paul Franz. Sorry, we're going to keep moving. I'm going to go really fast. Paul Franz is going to come out, who works for International Crisis Group, and he's a special advisor and data visualization specialist. Builds probably the best storytelling maps I've ever seen on Mapbox. So take it away. The floor is yours, Paul.
You're too kind, Chris, but I really have to start my presentation by extending a special thanks to the Mapbox developers team. I mean, without you, Chris, and the efforts of Marina and supporting our organization for the past several years, I mean, we've been able to do tremendous things, and I can't thank you guys enough. And thanks for having me here today. What I want to talk about is a project that I've been working on the past 12 years, and that is to really rethink and reimagine how we think about maps, as not only are they static or interactive products, but one of the things I took as my former experience as a journalist and storyteller is to bring motion design into creating maps. And as Chris alluded to, one of the things I use quite a bit is our Mapbox's scrollytelling library. But more specifically, I mean, the challenge that I've been trying to solve for the past 12 years is how do we reach high-level audiences, policymakers, leaders, world leaders? And one of the tools that we do to do that is Mapbox. And one of the primary reasons that we're doing the things that we're doing is that there's a ton of information out there. Policymakers don't have the time to read long books or briefings or even dashboards most of the time. And so for us at Crisis Group, the thing that really orients what we're doing is creating stories, policy stories that are easily comprehensible and impossible to misunderstand. And using Mapbox and Mapbox GL, this is one of the ways that we do that. So scrollytelling, a real big pillar of our outputs at Crisis Group. And as you can see here, this is a GIF of one of our most recent scrollytelling projects.
I don't think you're sharing screen, Paul. I'm going to interrupt you and make sure that you hit that share button because we're missing out on some great visuals here.
Indeed. Thank you, Chris. Thanks for catching me on that. Indeed. So what you have here on the screen is a preview of one of the most recent scrollytelling projects we've put together. This one was designed to reach out to the EU Parliament, talking about what crises and conflicts that they should really focus on in the next year. If you want to go see it for yourself, this is the URL. Of course, the recordings will be made available after this is all over. But if you're curious and want to dig deeper, go ahead and check it out. But of course, not all of our products are scrollytelling based. This is just a map that we released this week. It is just a single frame, single page application in which we show the growth of both legal and illegal Israeli settlements in the occupied West Bank since 1967. It's very straightforward. The user can drive the animation using that slider in the top left. And of course, another one big pillar of what we're doing at Crisis Group is satellite imagery research. And Mapbox Studio gives us a really great opportunity to be able to show off the custom imagery that we're getting from both Maxar and Planet Labs PBC. What you can see here is the country of Haiti. Unfortunately, it has not been in the news for good reasons lately, but you can be rest assured that at Crisis Group, we're doing really serious research, important research talking about the security situation there. But what you can see in this transition is the change over time of the Toussaint Louverture International Airport, in which Kenyan International Security Force has taken over the airport and built fortifications and encampments there. But that's using the Mapbox satellite base layer as well as a custom geotiff that we got from Planet Labs. So for front-end developers, Mapbox offers many options for you to be able to build maps with motion. With the scrollytelling library, it just takes a free account with GitHub and using GitHub pages to self-host it. If you are not familiar with the storytelling library, I highly encourage you all to check it out. You can see the GitHub link and repo here. And for nonprofits, I don't know how many people who are in the policy for nonprofit sphere, but if you are, you know that resources are limited. We don't necessarily have access to all the developer resources in the world. So using ChatGPT has been a great help. It's helped us bootstrap a lot of these complex projects. And Mapbox has its own now called Ask AI. But beyond this, I think one of the really cool things about mapping and map motion design is that if you're a video editor, there are also a lot of tools that are non-code that you can use to build animations with maps in Mapbox. And so we have our own branded series called Mapping Conflict. It's actually all built through a middleware with Adobe After Effects. If you're not familiar with it, check out GeoLayers. Also, Google Earth Studio has a tremendous suite for you to be able to create mapping animations. But you can, with Adobe, you can use Mapbox Studio and design your own base maps and then pull that into that workflow for custom design.
Awesome.
So
I
yeah.
You want to say one? Yeah, if you want to close out.
So follow me on X. I'm also on LinkedIn. But if you want to see more of our great mapping products, crisisgroup.org.
Excellent.
Thanks for listening.
Thank you so much, Paul. And yeah, anyway,
My pleasure.
I'm sure he'll be in there to answer any other questions you may have, but also go check out the portfolio. It speaks for itself. Thank you, Paul. All right, we're going to move on to Mehdi Narinejad. I hope I said your name correctly. And you're going to present BikeShare Pro. So take it away, Mehdi. Floor is yours. I think you're on mute. We can't hear you. One more time. I think you bounced off of mute and back onto it. There you go.
All good? Okay, great.
Okay, we got you.
So,
go ahead.
Thank you for the introduction. My name is Mehdi Narinejad. I'm a professor of civil engineering at York University, specializing in transportation. And today I'm going to be talking about a micromobility design tool that we've developed for different municipalities. And I'm going to be talking about the Vancouver version of it here that the city is currently using. So what you're seeing in this map right now is the bike share system of the city of Vancouver in Canada, where you have these yellow hexagons is where the bike share stations are, and that kind of shows the coverage of the stations. And these circles represent the inflow and outflow of the riderships. So in the red is inflow, green is outflow. So it shows like these ones are more outflow dominated, these ones are more so inflow dominated. And so the way we design these tools, the purpose behind them is to give cities the power to design their networks in a data-driven and a model-driven way and push their networks toward optimality. So we design these tools and we have a bunch of features on the left that they can pick from, and we have analytics here at the bottom, then they can evaluate and investigate. And the design exercises that we have is, for example, they can look at transit integration. This is where we use Mapbox Mapbox isochrone APIs to find out the walking distance from every public transportation station, and we investigate here how well bike share is integrated with public transportation. So where it's blue, it's very well integrated, yellow, it's medium, and red means it's not integrated at all. And we have different layers of background information, for example, population, age, employment, because, you know, the city staff, when they're making these decisions, they want to see what the underground layers are. And also flows at the road level. So this is where we use Mapbox Directions API, prioritizing bike riderships. And this allows us to capture what the riderships are going to be at the road network level as well. And we can categorize these based on total flow, regular flow, e-bike flow, and so on. And a lot of this is coming from the actual data, ridership data for the last 3 years that we're using to come up with these visualizations. But the main advantage of this, and what the cities are interested in using this for, is the interactivity and the model-driven nature of it. So what you can do, for example, is you can click a station, a location, and you can add a station. And when you add a station, there's a machine learning model running in the background, which tells you what the riderships are going to be from that new station to all the nearby stations. So the thickness of these lines represents the ridership levels. Is a graph neural network model that's running in the background. And in addition to that, as you're adding these stations, you can see that the road network riderships are also being generated. In addition to adding these stations, we can also change their properties. So we can click on them and like the dock capacity here, we can increase maybe from 20 to 30 something. And you can see these lines are now thicker. There's more ridership flow and so on. And the machine learning model in the background is using social demographic information, land use information, and the station features to come up with the estimates. In addition to that, it's also using points of interest, which we use Mapbox APIs to get. So when you're deciding to pick a location, in addition to using these points of interest in a prediction model, you can also visualize how they look here and make a decision on whether you want to add them or not. And as you're adding these stations, transit integration naturally also gets affected. So you can see the more stations I add, I can turn more of these reds into yellow and eventually the yellows into blue. In addition to this prediction, we also have a lot of different engines. For example, there's an optimization engine in the background that allows us to pick how many stations we want to add and allows us to add those. So here, I'm just going to show an example of this. You can first of all pick between these three criteria, what you care about, how much you care about accessibility, equity, and transit integration. And you can also add how many stations you want to add, prioritizing how much you care about the locations versus ridership. So when we value ridership a lot and we run this problem, we can see that the locations are kind of in the heart of the network, kind of in the surroundings. But when I devalue this ridership and I prioritize location specifics, you see that they're more so in the surroundings because they're prioritizing these features more so than they are ridership. And lastly, there's a lot of other features here. There's revenue prediction models, there's cost prediction models, and there is a save and load functionality. So the staff come back to this and continue the design exercise. And we don't necessarily just do this for micromobility. We also do it in other cases, and you can find out more about us on our website at interactiveor.net, which I'll just leave here.
Amazing. Thank you so much. That was, I feel like every single one of those different tools or different functionality you showed, I need 30 minutes to kind of analyze a little bit, but so much dense information packed into a small space, and would love to learn more about the modeling behind all of it. So this is just the visual layer, of course, and there's probably so much more going on. So if you have questions for Mehdi, go drop them in the chat. And thank you so much for presenting. Next, I would like to call out Kyle Walker. So thanks, Mehdi. Welcome. Yeah, the floor is yours. I'll just also say, if you do anything with maps on social media, you've probably seen Kyle Walker posting very frequently. So thank you for keeping us all informed about the great things you're working on. And floor is yours. You got 5 minutes to show us the R package.
Appreciate that. Well, thanks to everyone at Mapbox for the invitation. Just a little bit of background about where I'm coming from. So I'm a geography professor consultant working in population and spatial data science. So many of us in that world, we are very interested in data visualization. We're very interested in mapping, but we primarily work in R or Python, the premier two languages for data science. We might know JavaScript, but we probably don't. And I've been a longtime user and admirer of Mapbox tools, but I have done most of my work in R, which is a programming language and software environment for data science. And this summer, I released a new R package that really tried to bridge that gap, and it's called MapGL. And what I want to do today is just walk you through what I'm trying to accomplish with this package and some of the things that it can do. So our developers and data scientists don't necessarily want to spend the time setting up an entire front end or setting up an entire website, but they do want to use amazing Mapbox tools to visualize their data. And so to initialize a Mapbox map, literally all you have to do is type Mapbox.gl. And so once your access token is set as an environment variable, I've got an interactive spinnable Mapbox globe in one line of code. And the idea is that it removes a lot of the overhead for data scientists to use Mapbox tools, and they can have this right in their environment of choice. I've also built in a lot of transitions and animations. One of the fun things about working with Mapbox tools is you can have these really rich three-dimensional and interactive environments. So here, the fly-to method works seamlessly. I initialize a globe, and you can see in my IDE zoom into one of my favorite places, the American Airlines Center in Dallas, where my favorite team, the Dallas Mavericks, play. And you can, again, use this interface to build out a pretty richly interactive exploratory environment straight from R. And I mentioned, in R, we use it for data science. And so we're doing GIS, we're doing a lot of solving a lot of analytical problems. And I wanted to have a relatively straightforward interface to be able to use Mapbox tools to visualize the results of a spatial analysis. So the layers API inside of the MapGL package is designed to be fairly intuitive. It converts SF, or simple features objects, which are the main spatial objects we use for GIS and R, to Mapbox sources quickly and seamlessly so we can visualize it with minimal code. So here's just a very standard map that ships with a built-in data set of counties in North Carolina, adds it in as a fill layer. You can't do much with it right now, but it shows you how some of those paint properties get populated and translated over using this layers API. Scaling this up a little bit, we try to make in MapGL complex workflows relatively simple. And so the clustering capabilities of Mapbox GLJS are phenomenal. But for a data scientist, it can be a little bit tricky to get all of the options right. And so what I've done here, so I'm generating here 10,000 random points in Dallas, Texas. And all I need to do to create clustering, an interactive cluster map with sensible defaults, is just one additional line of code inside of the add circle layer function. So I run this and I've got built-in click to zoom for the clusters, really building upon what Mapbox has already created, but it's accessible to our users within the package now.
We're about a 45-second warning, Kyle.
Great. I'll speed it along. A couple of things I want to show you are connecting to R's vast ecosystem of packages. Here's a quick example that shows how to pull down census data using a package that I've written. And then we make an interactive Mapbox map, and this is showing median age across Florida. And the last thing I want to show you is how you can build out front ends as well. So Shiny is a web application framework where you can write R code to build web apps, and a lot of R developers use this. And so this is using MapGL, the Mapbox isochrone API, and Shiny to do interactive hypothetical analytics around coffee shop locations in Nashville. And so that's the overview. Check out MapGL. Just Google for MapGL, you'll be able to find it, walker-data.com/MapGL. Feel free to flip through the examples and give me a shout if you have any questions.
All right, thank you so much, Kyle. You're bringing back lots of fun memories of doing data analysis in R, and you've made it so easy for people. So I hope this gets people on their way quickly.
Excellent,
right.
Appreciate it.
Yeah, thank you. All right, next we're going to bring out Gustavo Gonzalez, who's going to preview show and tell urban geometries. So it looks like a data analysis and data visualization dashboard for cities. So take it away, Gustavo. The floor is yours. Welcome.
Hi, Chris. Well, how are you? Hi, everybody. So
Great.
I'm going to share my screen.
Go for it.
Okay. This is a tool I built. I'm Gustavo. I'm from Paraguay. I'm an architect and an urbanist, and I've always been interested in maps. So this is a tool I built for fun. It gets the data from inside Airbnb, and it tries to compress so much information in one small place. So all depends on this point. This point is what controls everything. So this will be the user, and when you drop the pin on the map, it reads the information that has around him. It creates this isochrome that is done with Mapbox that you can control here. You can change to do for bikes, for car, and you can change the distance that this context is getting. So it takes a little while for read, but it gets there. So you here have a small map that also controls the pin. You can move this, you can zoom and move in the pin in this place too. In this small map, you can see all the city, all the city of London, and it shows you really quick where are the places that have the higher and the smaller values. In this tool, all the points are real estate properties. So every one of those is classified in three categories. That is the small prices, that is this red place. So if I want to filter only the prices that are small, I'm just using this tool to filter. If I want to see only the prices that are in the middle, I use this to filter it as well. And I want to see only the properties that have the highest value, I filter for this too. In this place, I have the same filter, but this is for time. This is not for, I have so many points right now, so I'm going to make a little small. And it automatically reads all the information that is in this area. So over here, I'm filtering by time too. This is only 2024. The properties that are being added to Airbnb in this period. So in the map, we have the classification as well. These pins, the higher they are, they represent the higher prices. And we have the information for each one of these, so that we have the pictures that are in Airbnb. So
can I ask
over
super
here,
quick, are you using any kind of 3D overlay, or are those just extruded polygons?
for this, I'm using DeckGL. This is the grid cell layer from DeckGL.
Great. Sorry to interrupt. Keep going.
No, thank you very much for the question. And this is the place where you classify the list that Airbnb has. So if you want to see only the top properties, you get in this place, you get to see it. And you can also classify by rooms. If you only want to see what with 2 rooms, there is less information, but you can do it too. And in this place, you can search by location. And I'm not from London, so I don't know anything about, but you can travel with this too. I were to another place, but.
Excellent. Is this all coming from an API, or do you have like a static data set with all these all this data on the listings?
It's all coming from an API. I downloaded the data from Airbnb inside Airbnb, and it's coming from an API that I managed to build with Postgres and Django.
Excellent. Okay. We got about. Go ahead.
This is the last part when you can download the data. You have cluster here of the classifying by prices. Every cluster here recognize the properties by prices, and you have here you can order these ones for distance, for price, for the rating they have on Airbnb, or for the reviews, the quantity of reviews. So I think that's all I have for this.
Okay, thank you so much. It's amazing how you've been able to pack such a dense amount of information into a small space and come up with this really great, colorful, stylish, and very, very easy to use user interface. So thank you so much for presenting. And with that, I will call out our next presenter, Carrie Bannon, who is a librarian at UNC Chapel Hill in North Carolina. And she's going to present the U.S. historical counties through time. So data visualization of historical, I guess, yes, historical county definitions. Take it away. Floor is yours.
Hey, my name's Carrie Bannon. I just finished my master's in library and information science at UNC Chapel Hill. And I created this map to visualize the changing shapes of U.S. states and counties over time. The data comes from the Newberry Library. Then it was imported into QGIS, cleaned up, exported as GeoJSON, and then converted into tiles through Mapbox tiling service. So everything is built in Mapbox GLJS, and every polygon has a start date and an end date, uses data-driven styling to kind of, there's patterns, and and then it only shows the polygons that existed during the date selected on the slider. I was also able to integrate data from nativeland.ca, which is a really cool project that uses Mapbox to show the locations of native and indigenous peoples. So that way, it adds a little more context to the map so that you're not showing colonization happening in an empty country. So it adds a little more context to that history. And it started off as a proof of concept to visualize research data for my thesis. I work in an archive, and we work with a lot of historic sources, and for people who are visual learners, this gives them another way to understand a time period, whether they're looking locally or at the whole country. Lots of ideas for expanding this map. Because I'm self-taught and focusing on, library things, I use Mapbox because it let me just worry about the data, and I knew it was going to be pretty. I knew it was actually going to work, and it was going to be really fast. And it worked out really nicely.
Great. How has it been received? I mean, have you done presentations with I assume there's, some community at your institution that would be very interested in kind of analyzing this over time. How's it worked out?
This is the first time I've showed it. I've shared it with a couple coworkers and some friends who are social studies teachers who are very excited about it, but I haven't really gotten to share it too much yet.
Okay. And did you learn anything? Anything jump out at you after seeing this in a kind of new way, in a new presentation that you didn't know about before?
Oh, tons. I mean, just kind of things you never really think about. Like, my sister lives in Oregon, and it wasn't even a state for a little while. I live in North Carolina, and the county I live in is Durham County, which is here, but it didn't exist until the late 1800s. So if you're looking for records in Durham County, you need to look in Orange County and Wake County. Things like that I can just see being helpful for people who just may not have thought about the history of these things changing.
Great. Yeah, I'm actually from Maryland, so I know that my home county of Montgomery County used to be part of Frederick County. Can we see that?
There.
That would be fun.
There we go.
Yeah, right there.
Here's Maryland. There we go. Yeah.
Am I right? There it goes.
Yeah.
It was
Yeah.
once.
Oh, yeah.
Here we go. Okay. That's wonderful. Okay, thank you so much. Actually, I will ask one more question because we have a teeny bit more time. Did you have web development experience before putting this together, or is this kind of your first foray?
Just a little, only HTML and CSS. So I was learning JavaScript while I was learning how to make it.
All right. So I have a very similar story of Mapbox and all these kind of easily accessible front end tools being a good gateway to being a more robust web developer. So good luck with you on your journey, and thank you so much for sharing this project with us. Okay, next I would like to call out Luke Decker, who's a senior lead map engineer at Sicilian Partners. And he'll be showing us reinventing residential real estate maps with Mapbox. So we're going to see some more real estate on the screen. Take it away, Luke. The floor is yours.
Thank you, Chris. First and foremost, thank you, Chris. Thank you, the Mapbox team, for letting Sicilian really talk about some of the awesome stuff we do with Mapbox here today. So as Chris said, I'm going to take you guys through some of the rental maps and new projects that we've been doing here at Sicilian Partners. 5 years ago, Sicilian set off to really innovate in the changes needed for the ever-changing real estate market with a suite of digital products. For instance, we do lot management with a product called the XO, where we allow builders and developers to store, manage, and use data. And we also have a point of interest product called Explore, where community developers can tell their story through interactive maps, of course, using Mapbox. So just some use cases. This is Talisker Park, just outside of Park City, Utah. Mapbox came in a huge help with these guys, especially when it came to transforming their marketing map into a 3D interactive experience where we leverage Mapbox Studio's ability to use 3D topography to show the mountainous region of Park City. And Mapbox has really come in handy when it comes to showcasing large amounts of data, especially with Lakewood Ranch down in Florida. There are over 33,000 acres. And if it wasn't for Mapbox, we wouldn't be able to make an interactive experience which showcases this giant master plan community. So it's easy to say that and see that with Mapbox, we've really been able to leverage a lot of the solutions, whether it's Mapbox Studio, making a lot of custom maps for our clients who are constantly updating new phases or adding new innovations to them or changing the styles around. And then, of course, Mapbox GLJS, which allows us to build awesome UI, UX, and products around the awesome maps that Mapbox has. But recently, we were challenged by a client for kind of a newer project that was a little outside of our comfort zone, and that was with rental maps. So we had a client just outside of Houston, Texas, ask us, hey, can you make a build-to-rent or rental map using your consumer maps? And that came with a few challenges for us. First and foremost, it was a different type of database. We had to leverage Mapbox in order to bring in this third-party database, which didn't have typical identifiers that you would find in GIS data, right? So maybe not the usual addresses or usual IDs. So trying to create a connection there, we had to redo our side panels to make sort of new filters that users could use to better find the home that would be their next home. And finally, we had to figure out new ways to show details of the location, so amenities inside and outside of these rental communities in Houston. So as I said, we had to really rethink how we were using data to create real-time inventory maps for these rental communities. So that meant taking that third-party database, putting it through Postgres, loading it onto our maps, but then also having it coincide with Mapbox so that we could have a real-time inventory map that users could see, was this rental unit available at the time, and even were there point of interest nearby that would be interesting for that resident to possibly move in. As I said, we had to change our side panel and add new filters, which wouldn't have been possible without Mapbox GLJS. So as you can see in the GIF here, we had to put in move-in date filters, add additions to our bed and bath filters, as well as add new floor plans and elevations so that users could easily navigate. And we even added some new features to the individual units themselves, like floor plan renderings, and even some 3D tours that users could go in when they clicked on a lot with Mapbox and be able to see within the unit itself before they moved in. And finally, one of the last innovations, and we've always done this with our Product Explorer, which is a point of interest solution with Mapbox, is we really worked on how we showcase point of interest for these rental maps, because really rental maps have been just sort of these static lists of units on websites and have never really been truly interactive and showcased the location context. So we really had a lot of fun building POIs around so that renters could see, oh, is the pool nearby, or is there a nice place to eat just outside of the community? So in closing, I just want to say again, thank you, Chris. Thank you, Mapbox. Without you guys, we wouldn't be able to make some awesome innovations in real estate. And at the end of the day, without the awesome stuff you have, we couldn't put our clients on the map.
Awesome. Thank you so much for sharing that. It's really great to see this kind of rich UI coupled with the map and all the kind of changes happening in real time when you interact with those filters. So hopefully you're creating huge amount of value for your clients. So thanks so much. Any other questions for Luke? Go ahead and ask him in the chat. And let's bring out our next presenter, Paul Finley. Paul Finley is the CEO and lead developer of Hiker, which I believe is a hiking map. Well, I probably oversimplified that, so I'll let you take it away and do the proper introduction. But floor is yours.
I'll just share my screen here, hopefully successfully. You able to see my screen okay?
Looks great.
Great. Okay. So yeah, I'm just going to be talking to you briefly about Hiker and how we're using Mapbox and AI to improve our user experience. So yeah, just to give you a little bit of context, Hiker is a hiking platform and toolkit, and we've had almost 1 million users onto our platform to date. We utilize Mapbox to provide our customers with a collection of the best hiking maps from around the world. So we work with incredible cartographers from the likes of Purple Lizard based over in the States, Harvey Maps in the UK, or East West Maps in Ireland. These guys make incredible maps, and we're utilizing Mapbox to show these maps to the world and show these to hikers to let them plan some really, really great trips. Our CXO, Pete, he's always facing the challenge of, making our user interface incredibly simple for our users. And we receive, a significant amount of users to our platform that aren't overly au fait with maps and aren't overly au fait with apps, even in themselves. And so can sometimes struggle to use our user interfaces, and we're constantly trying to make it a bit simpler. But recently we launched something called Trail GPT, which is essentially an AI assistant to plan your hiking treks and to ultimately help you, make the right decisions when you're going to be getting out hiking. But this is what really got us thinking, how can we combine all of the amazing data that we have on great trails around the world, Trail GPT, to build out some amazing function calls and then have that to ultimately work with Mapbox. And so I'm going to give you guys a little demo here. And I do think the saying will soon be not to work with animals, kids, and now AI when you're doing demonstrations, because this may not work, but let's give it a quick go anyway. I can quickly jump into the map here and type in, show me the best hiking trails in the world. I can hit submit. And then in and of itself, the AI hopefully will start to manipulate the map. So there's no kind of internal controls here. We're passing it the capabilities to control the map, to move the map, to add different polylines, polygons, annotations to the map, and then it can move it around there. So anything from getting a great tour of brilliant trails from around the world, Tour de Mont Blanc, I've actually hiked that trail myself, a beautiful trail. I've even walked on some of this, Hadrian's Wall Path. It can just bring the user around. And again, it's the combination of function calls that we are passing to the AI that it's allowing it to call back and manipulate this to show all around there. So from our perspective, the user experience here is all about the user in plain language can kind of, hey, I'm looking for some really great trails in, the south of England this coming weekend. Can you give me a quick tour of some options? And then the AI in and of itself can control the map and show those options directly to the users. But this can go even further and wider. If a user wants to get a quick guide of, on the map, what happened during World War I, or again, any sort of abstract any abstract ideas that they have of how they want to view this information there, they can use natural language in order to see this information directly on the map. So even where I query something, maybe a little bit more abstract, like show me the Triple Crown of hiking, and I submit that, it can then figure out all what that means. And thankfully, it has realized that the Triple Crown of hiking now, this is why it said, don't work with animals, kids, and AI. It's picked the wrong trail, of course, and it said it's showing the Pacific Crest Trail. It's not. But I think you can get the idea of where we're going with this. And yeah, ultimately, this is our goal in order to build this out further to, I suppose, create a natural language-based approach in order to allow users to interact with our great maps and the Mapbox software.
That's amazing. I wonder if this is maybe this is a better candidate for the Triple Crown. Maybe we've got it wrong the whole time.
it potentially could be, yeah.
Okay. That's great. So there's 30 seconds left. Is there any more you can tell us about, like where all this data comes from? Is there a lot of maintenance involved to keep everything up to date, or are you using third-party sources?
So we're mostly using all of our own internal sources. We've got all of our own location lookups, but I suppose that the big challenges around this right now is token usage. That you do see significant token usage when doing this. And so what we've been trying to do in and of ourselves is to fine tune mini models that different organizations might offer, which helps to like drastically, by almost a factor of 500, bring the cost of this down. So that's really the challenge where we are. If we can get the costing right on this, it could then become, I suppose, something that we can, release it to our production environments.
Excellent. Okay. Thank you so much. Again, we're happy to see mobile apps on this show and tell as well, because obviously it's more dominated by web apps. So this is really great to see. And thank you for sharing this wonderful innovation. Okay, we got 2 more presenters left. Thanks, Paul. Next one I'm going to bring out is Sorami Hisamoto, software engineer at Maroon Incorporated. I don't know if I said that properly, but I'll let you correct me. And you're going to share a storytelling about transit stations in Tokaido. Take it away. The floor is yours.
Hello, this is Rami. Nice to meet you. So I'll talk about storytelling today. So hi. So my name is Rami. It's called Mierune. We are a geospatial company in Japan. So it's actually 1 a.m. Saturday in Japan. Hello, everyone in the world. So today I would like to show my side project, actually, not from the company. So let me change my screen. Can you see my map now?
Looks great.
So this is great. So this is my map. So Tokaido is this historical coastline road from nowadays Tokyo to Kyoto. So you can kind of scroll through these different stations, the rest areas, and then you get to see this ukiyo-e painting, which is like the Japanese painting style in like 18th century or so. You can try this. I'll put the link to the chat. You can try it by yourself there. Look, I'll go back to my slides now. Okay, so these are the maps and storytelling, which I've created obviously with Mapbox. Try it by yourself. So again, so 53 stations of Tokaido is an iconic rest area in coastal road between Tokyo and Kyoto, renowned for these ukiyo-e paintings. So first of all, storytelling. So what is it? I'm sure many of you have heard it. You've seen that in Paul from Crisis Groups, like earlier presentation. So it's the word combined between scroll and storytelling. But first of all, I want to talk about why we want to do storytelling. So scrolling is kind of easier to do than like clicking. So I'm sure you've seen a lot of storytelling in places like the New York Times and other interactive journalism articles. So some articles say that people like they're kind of myths that people don't really scroll the screen and don't see the bottom of the page, but actually there's no evidence for that. And the question is that like if they would scroll slowly enough to actually read the content. So scanning is the reaction, but reading is a choice. So the structure and the rhythm of the article, the content is important. So there's an article in Nightingale, the data visualization journal. They talk about the storytelling like in 2020. So they say that this guy said that storytelling helps solve the people's problem of limited ability to kind of consume the information. So we can kind of spoon feed our audience so they can it's easier for them to digest the content. Another thing this person explained, which I found interesting, was that he said that storytelling is kind of the mimicry of video, but you can kind of indirectly control the speed and you can kind of rewind and do kind of different kind of stuff. But anyway, so this is developer show and tell. So let me go into the implementation detail. So there are different ways to do storytelling, but the basic element is intersection observer API. So you get to use this API to kind of check the target elements, and then when they enter the certain range, you can execute the certain commands. And there's a nice library called Scrollama, which kind of sits on top of Intersection Observer API, and then you get to do kind of the storytelling kind of stuff easily. There are other libraries, but I think Scrollama is pretty good enough for all your needs. And there are other libraries like GreenSock, GSAP have the plugin, or the Svelte, the web framework, has this person show some storytelling presentation patterns as well. And of course, Mapbox. So Mapbox has a storytelling template. I'm sure many of you have seen this, but it's not really a library, but it's a template, and you don't need to kind of code everything, but you can do a little bit of coding to create a nice storytelling article. So case study about my Tokaido storytelling implementation. So this is the map. And then the data, I've used most of them are public domain data or the open data, which I kind of prepared from different places like Wikipedia and so on. And then the code. So of course, Mapbox, and then I've used different web technologies like Svelte, the web framework, which I think it goes well with data visualization, and ToughJS, which calculates geospatial stuff. I used it to kind of calculate the distance and the direction to the next station, and Scrollama for the scrolling. So I don't have much time to explain this code, but it's pretty simple. The storytelling looks quite amazing as a user, but like it looks like magic, but it's actually quite easy to implement. So have a look at the code and data. My Tokaido storytelling code and data is publicly available on the GitHub. So if you're interested, have a look at the code. That's all for me. So if you're interested, keep in touch. Thanks.
Excellent. Thank you so much, Sarami, and thanks for sharing the code so other people can learn from this experience or learn from your progress on this map. So look forward to checking it out in more detail afterwards. And if you have questions, drop them into the chat. Maybe Sarami can answer them. Okay, bring out our very last presenter. We're doing great on time. We had a couple no-shows, so we're doing great on time. So I'd like to welcome as our final presenter, Wolfram Hemprel, co-founder of HiveKit, who's going to share an asset tracking, operations management, and process automation unified platform. I'm very excited for this one. So take it away. The floor is yours.
Thanks so much, Chris. Yeah, it sounds very bold if you say it like that. I'm Wolfram. I'm a co-founder of a startup that built something that we rather ambitiously call an operating system for the physical world. It does effectively 4 things. It tracks assets, moving vehicles, machines, sensors, and the likes, and it visualizes them on a 3D map. And we're using Mapbox for that, and we're super happy with it. We've been able to add a 3JS scene on top of Mapbox and sync the whole thing up, and the whole thing just works a treat, basically, right? And you can add all sorts of data visualizations on top. You can, for instance,
You're not quite sharing yet. I just want to make sure you're aware of that.
Oh, that's not good.
No, that's not okay. Yeah, sounded great. Sounded great, but it looks even better.
Looks even better. Yeah, effectively, you can see all your vehicles moving in real time. You can see sensor values visualized and the likes. You can see it right now?
Yeah, looks great. I see.
Perfect.
Well, I don't know. Looks like they're stuck in traffic, and I live about a mile from here. So,
yeah, it's going to be quite bad tonight, I'm afraid. But it allows you to overlay all sorts of user statistics on top of that, analyze traffic patterns and likes, see obstructions, and pull in data from all sorts of sources, right? So you can, from simple things like adding some GeoJSON on top to much more complex use cases like analyzing historic bottlenecks, things like that. But the goal of what we're doing isn't so much in just visualizing. It isn't giving you the ability to actually use this data and make it actionable. So the bulk of our customers are from areas like farming, mining, and the likes. So in farming, for instance, you would be able to not just see what's happening on your farm, but to overlay things like soil metrics, sensor reading, and the likes, to have real-time overlays of metrics that are currently happening on your site, and even to direct your workforce by basically playing Command and Conquer. You just select units, you can assign tasks, and HiveKit translates these into individual actions, sends them to a mobile app that comes with it. And each person working on your farm or your mining site has a constant companion that tells them, here's your current to-do list, here's an optimized route for that, here's what's up next. And by the way, make sure you're not entering the security zone that you don't have clearance for instance, right? Now, the goal of HiveKit isn't really just to have human operators manage things proactively, but to automate the whole thing. So a lot of what you actually do is you write automation rules, looks a bit like that then watch for certain events, watch for vehicles entering a zone or certain loading state or any kind of data-based events, and then trigger actions based on that. And you start building up these rules, and it sort of starts up very, very simple, right? So you could easily see a rule where you say, hey, if there's a traffic congestion around this area, route around that. Or, hey, we know there's a lot of plays ending along Broadway around 10:30. So make sure that plenty of taxi cabs are waiting in this given area, right? And you build these rules up over time, and increasingly your operations sort of run more and more on autopilot, whereas HiveKit facilitates the execution of these rules. On the technical side, so developer show and tell after all, we build out a sort of 3D library of objects around everything. We merged a 3JS scene into the Mapbox GL API. And we made sure that the camera is synced with that, so that whenever you move or zoom the camera, whenever basically the Mapbox map renders, we inject our scene and update it accordingly. And that seems really, really dodgy as an implementation, but actually it works beautifully at solid 60 frames a second. We can visualize thousands and thousands of objects at the same time, and it works pretty much flawlessly. That sort of summarizes what I wanted to share.
All right. Well, you're right at time. I have to say this almost feels to me like one of those fake user interfaces that you see in movies when there's like a hacker who can control the street grid and like, know everything that's happening in every single building at every time. So hopefully you get there at some point. But this is amazing. And thank you for sharing the technical details and how you're, complementing Mapbox GLJS with this overlay with all these great models and all this great visualization. So I wrote in the chat, this is a tough act to follow, so I'm glad you went last.
Cheers.
Okay. All right, thanks, Wolfram. So yeah, appreciate your time. And if you have questions, drop them in the chat, and then I'm going to do kind of a closing here. So thank you so much. All right, give me just a moment to share my screen. And I will jump back to this slide just to remind you who we heard from today. Okay, so as a final word, thank you so much for attending this developer show and tell. We used to do these in the Discord in a kind of more casual kind of way where people would just sign up each month. So we'd love to do these more frequently. If you're interested, let us know. I have to give a plug for the feedback survey. So everyone who attends a build session is going to get a feedback survey. So think about this session, what you enjoyed about it, what could have gone better about it. We'd love to hear the feedback. And we'd also love to hear what other kinds of developer community events and ideas you might have. Because if you're like me, you're fired up after seeing such a huge diversity of projects presented today. So as a final thought, I just want to also say, diversity, like look on this screen here, there's people from all over the world, from all different backgrounds. We've seen beginners, we've seen full stack, very sophisticated software engineering projects. And it kind of runs the full gamut. And I think that's what's great about these tools is that they're accessible to whoever needs them to build for whatever they have, whatever they can dream up. And we've seen kind of a great variety of every different, avenue, use case, subject matter area. We've had academic things, we've had data dashboards, we've had very practical real world, projects that let you visualize what's happening for like mobility and for the last project we saw for, what's happening in the real world. So anyway, you saw it here. Thank you so much for coming to this dev show and tell. Thank you for attending Build with Mapbox, and keep building. We look forward to seeing what you put together, and we'll see you at next year's or at the next build session. Take care, everyone.